Hello, today we are going to be learning how to answer balanced equation calculations. So how do you recognise balanced equation calculations? Well, there's two key points that you need to look out for in your question. First things first, they have the word calculate in the question. What that means is you're going to have to be doing some sort of calculation to get your answer. And secondly, they're going to be a balanced chemical equation somewhere in the question. Now, questions can be over multiple pages, so it's worth taking your time and having a look to see where your balanced chemical equation is going to be. These questions are worth 3 marks. Usually I say to answer the question in 3 stages. What that means is you can get a mark from each stage. Follow through is applied in these questions, so what that means is if you accidentally make a mistake at the start of the question, if you continue on with that wrong answer, you will still get credit for the rest of your answer. Now, one to remember here is units. Usually we have to write units at the end of a question, but however, if it doesn't ask you for the units, you don't need to write them. For example, it could say calculate the mass in grams. What that means is they know it's going to be in grams, so please ignore it. If you write a wrong unit here, you will get a mark taken off you. So the question that we're going to be doing today is an introduction to higher calculation. It's in page 12, it's the very first titration calculation question. I'll let you go and have a little look at it, but as always, it's going to be at the top of the page each time I do the answer. So here's the question. In a titration experiment, 25 centimetres cubed of a 1 mole per litre hydrochloric acid reacted with 25 centimetres cubed of a sodium hydroxide solution. Calculate the concentration of the sodium hydroxide solution. So what we're going to do, usually I always tell you to bring in some highlighters into the exam so you can highlight the key parts of the question and know really where you're going to go with this. So the key kind of points here is you've got 25 centimetres cubed of hydrochloric acid, which is 1 mole per litre, and you also have 25 centimetres cubed of sodium hydroxide solution. And what are we being asked for here? We're being asked to calculate the concentration of your sodium hydroxide solution. So let's digest. Usually I go with a tick and a question mark concept. The tick meaning that we have lots of information about this substance, and the question mark meaning we're going to be asked about it. So let's have a check. Yep, we've got some information about hydrochloric acid. We have the volume and the concentration, and we only have the volume of sodium hydroxide. So how do you answer these questions? I go with a 3-step. Step number 1, work out the number of moles of your hydrochloric acid. Step 2, work out the number of moles of your sodium hydroxide. And finally, step 3, work out the concentration of sodium hydroxide. So here's the question. I always take a couple of different highlighters in my exam so I can highlight the key parts of a question. So that's what I'm going to do here. So the most important thing to start off with is your hydrochloric acid, because you've got lots of information about it. Usually I split my page up into 2, and we're going to take the left-hand side to be your hydrochloric acid. So what does it say in the question? Well, we've got a concentration of 0.1 moles per litre and a volume of 0.025 litres. Notice how I've put litres and not centimetres cubed, because it has to be in litres in these calculations. If not, you'll end up with a ridiculously large number of moles, which isn't correct, so you're going to have to make sure that you've got your volume in litres. Having a look at the data book, you'll see that the number of moles equals the concentration times the volume. Sub into your equation 1 times 0.025, which is going to give you a number of moles of 0.025. The second step is to work out the number of moles of sodium hydroxide. So if we use our balanced chemical equation, we can see that hydrochloric acid reacts with sodium hydroxide in a 1-to-1 ratio. Well, what does that mean? Well, we've got 0.025 moles of hydrochloric acid, so we're going to have the exact same of sodium hydroxide. So we're almost there. We know we've got 25 centimetres cubed of sodium hydroxide, so let's make the right-hand side our sodium hydroxide side. So we've calculated we've got a number of moles of 0.025. We also have a volume of 0.025. Again, it's in litres, not centimetres cubed. This time we're going to rearrange the equation. The concentration equals the number of moles divided by your volume. Again, sub in your information. 0.025 divided by 0.025 gives you a concentration of 1 moles per litre. And that's us finished. So hopefully that has been useful for you to understand how to calculate your balanced equation calculations. They can be quite tricky. They do come up quite a few times, so it's always worth giving a practice on these calculations. Hope you have a nice day, and I'll see you again later.